Hello, good morning, good evening, good afternoon, and welcome to my session on securing your modern Azure SQL database deployment. I am Armando Lacerda, and in this session I'll be sharing some of the features available in the cloud to make your database and your data in your database more protected. So let's get started with the introductions. Again, my name is Armando Lacerda, and you can see on the right side of the slide some of my contacts. You can connect with me through LinkedIn or Twitter. I don't tweet much, but when I do, it's usually some information that I found valuable from fellow other MVPs or MCTs, as well as news from the Microsoft platform, especially in Azure in the data platform. I work with Wintellect. I'm a trainer for Wintellect. I'm also a consultant, dependent consultant. And with Wintellect, we do a lot of training. I've been doing training for them on the Azure platform and also development for Azure. And Wintellect, it's a great source for knowledge. They have a bunch of free resources. Check out their website. In this particular session, I really want to focus on how to make our data more protected, since data privacy is so important. We have seen so many cases of data leaking recently. So we're going to go over self-contained databases feature and how it works, which is the foundation for everything else. And then go over service principles and manage identity, authentication, authorization, and two great features called data masking and encryption. I have presented this particular session here live with Wintellect on August the 8th, but we had some distractions during the session. The environment was not very well prepared and got some distractions throughout the presentation. So I've decided to record this one here. I hope this one is going to be more clean and you can benefit more from this, from the features and the knowledge I'm going to share with you guys. So please, again, you got my contacts on the right side. Make sure you connect with me. If you have any questions, you can either post on LinkedIn or send me a tweet. If you're old-fashioned, you can also use emails, right? But either way, don't be strange. Send me questions. Send me any questions you may have as we go along. So let's jump straight into the first topic, which is self-contained databases. So what is this all about? Well, self-contained databases is a feature that came out in SQL Server 2012, and not that many people paid attention to this feature, because when we look into on-premise deliveries, and back in 2012, the cloud was on its infancy in terms of general availability, so not that many people were really looking to the cloud, and on-premise, it didn't make much sense. The things were already working in terms of security and how the database got deployed. We had this thing called orphan database logins, which you're gonna take a look at here in a second, or orphan database users, I'd rather say. But the point is, it came out in 2012, not many people pay attention to it, but actually the cloud was behind the purpose of this particular feature here. So in order to better understand it, let's do a quick review to make sure we are on the same page on how database authentication works and how we grant people permission to work with the data in the database. In the beginning, on-premise, of course, in SQL Server on-premise, this is the scenario we used to have, right? Actually, still have, because we still have SQL Server on-premise, but this is the scenario we have. We have Windows authentication, usually Active Directory. So we create users in our Active Directory infrastructure, and we create global groups to have these users aggregated, by whatever criteria we want to have them aggregated. And if we follow best practices, we would have Windows local groups on the servers where the resources are, and would give permission to these local groups to the resources in a server, and we would have those global groups into these local groups. Regardless of the recipe we follow, we're gonna get one of these three guys here, permissions in Windows. So it means that we would be creating Windows logins associated to these Windows principles in Active Directory, and then we would give this Windows logins permissions on the databases on a particular SQL Server instance. That's how things work, right? That's how things work in Azure, in SQL Server on-premise. There is also the option to create logins in SQL Server itself, called SQL Server logins. And the idea is if some other server, some other application running on a host that does not belong to the Windows domain wants to use the data in the database, they would be able to authenticate using regular SQL Server authentication, not using a Windows authentication. That's done through a username and password. Can also be a certificate, some other options in there, but usually a username and password, and people connect to the instance and then to the database. What's important to take away from this particular slide here and the process is our users, people who need access to the database, they must authenticate to the instance and then to the database. That's the most common scenario you see out there in SQL Server installations on-premise. What changes when we go to the cloud, again, is that feature, self-contained databases, that came out in SQL Server 2012, but it's an option in SQL Server 2012, in SQL Server on-premise, I'd rather say, regardless if you want to use it or not on-premise. But when we go in the cloud, that is the way it works. This is the only way it works. So in the cloud, the picture seems similar, but there are very important changes in here, and I want to call your attention to these changes so you can understand how to better secure your data and your database. So in the cloud, we still have Active Directory, but it's not the same Active Directory we have on-premise. What we have is the Azure AD. So the first thing is, if I want my on-premise users to be able to access my database in the cloud, I must synchronize my Active Directory to Azure AD and synchronize their accounts, and their accounts must exist in Azure AD. You cannot authenticate integrated with Azure AD if the account doesn't exist in Azure AD. Makes sense, right? So you have to have the account on Azure Active Directory. Once the account is there, what we have are just groups, right? We don't have those two levels of groups, global groups or universal groups. We also have in Active Directory and domain locals and local on the Windows Server itself, right? We don't have that many types of groups. We just have groups in here, secured groups in Azure AD. There are some other kind of groups that comes from Office 365 as well, but for the purpose of this presentation here, is just a secured group, so just groups. So we can have either the groups or the users associated to an Azure SQL Server. So see, two distinct instances, right? We have the logical Azure SQL Server, and you have the database down here. And in the previous slide, let me go back one here, you'll see that it's very close to each other. So like the SQL Server instance embeds in a way the database. The database is on the server where the SQL Server instance is running. So it's very, kind of physically tied up together, because this database cannot be in another host and is in the same computer all the time. While in here, there is some sort of disconnection, right? They still talk to each other. They belong to the database, belongs to the server, but they are deployed on distinct infrastructure resources under the hood. So that's why many documentations you're going to see the Azure SQL Server being referred to as the logical Azure SQL Server, not the actual installation of a SQL Server on a server. Because in the cloud, we want things to be logical because we want them to migrate all the time. So the server may migrate to another physical computer, physical host, as well as the database when things fails under the hood. The bottom line here is my Azure SQL Server. It's a logical element, and I can grant people permissions in the Azure SQL Server. But the point in here is to grant permissions to AD users to my Azure SQL Server is not to give them access to the database like we used to do on-premise. The idea here is when I give people permission to the Azure SQL Server, not the database, but the server, what we want to give them is permission to manage the service in terms of, for instance, scalability. I want to give people permission to scale up or scale down manually an instance when more processing power is needed, right? Or I want them to be able to manage the backup policies or the security policies. The whole point here is when I give permission to Azure SQL Server to AD users, I'm giving permission to administrators of the service. I'm not giving permission to see the data. So when I give people permission through the Azure SQL Server, I'm not giving them permission to see the data. Only I'm giving them permission. I'm giving them permission only to manage the service, and that is true for almost everything in Azure SQL Server settings and giving permissions in Azure through Azure SQL Server platform as a service settings. The only exception to this is one particular setting that will be demonstrated to you in a second, called the server admin. Whoever you add on the Azure SQL Server service as a server admin, they will be able to connect to the database, and actually they'll be able to connect to any database that is in Azure SQL Server logical service. So the server admin, it's pretty much the SA we used to have on-premise, or the sysadmin role in Azure SQL Server on-premise. So whoever you add in there, and you can add either only one person or a group or AD group, Azure AD group to be very specific. Whoever you add in there, they will be able to connect to any database on that particular server, and they will be able to run queries on that database. Everybody else on Azure SQL Server service permissions, anybody else that has been granted permissions on that level will not be able to see the data. So that's a very important change, right? From on-premise deployment and on-premise design. The other thing here is when you create an Azure SQL Server, you are required to give a username and password that will be the SQL Server login for the instance, right? For the Azure SQL Server, not the database yet, but the Azure SQL Server. So that one, again, is for backward compatibility. So environments where AD is not supported, Azure AD authentication is not supported for whatever reason, we can still connect to the instance using a regular backward compatible username and password authentication, right? Like some Unix platforms, some Java JDBC connectors. In some places they are running from servers, they are not able to authenticate to Azure AD. So that's you would do it on this on the SQL Server instance level, right? The logical server. The bottom line is you can have only one SQL Server login at the instance, and you can have only one server admin at the instance level. But the server admin supports AD groups, while the SQL Server admin doesn't. In terms of best practice, we should avoid use SQL Server logins. And as a matter of fact, we have to create one when we create the server, but we really don't want to use that for any sort of management, right? We want to do these things through Azure Active Directory. So now that I know how to grant permissions to the logical server, to the Azure SQL Server, how do I grant permissions to user to actually see the data? Since that is not the right way, have everybody as server admins to see the data is not the right approach, right? The idea is by leveraging self-contained databases. The idea of self-contained databases is I grant people permission not through the server, but straight to the database, this green line over here. So in Azure SQL Database, I can go into the database and say, you know what? I have this particular AD user, or I have this particular AD group, and I want to give them permissions to the database. I want them to be able to come in and connect to this specific database and no other database on whatever server this database is connected to, or as a matter of fact, any other server, any other database in my Azure subscription. So this is the right way of doing this, right? This is how it works, and this is how we want to implement. This particular feature also works on-premise. We can create self-contained databases on-premise, and it's usually a better approach because if I go back here a couple slides, when we are on-premise and we do this, database users, the database user is connected to a Windows login, to a SQL Server Windows login. And if something happens to the server and I have to restore this database someplace else, when I restore it onto another server, all the users, database users on this particular database, they'll be marked as orphans because their logins, there's a great chance that their logins will not be present, will not be registered on the instance where I have restored my database. The Windows logins, they are kept into the master database, and if I restore this on an already existing server, there is a chance that those logins will not be there because I won't be able to restore the master database on the new server. That being the case, I have to extra work to start connecting everybody else, all the database users, because I don't want to lose the grants to new logins, and this is an extra effort. We don't want to go through that, right? So the self-contained database, which is this picture here, goes around this. It actually allows me to associate the AD users into the database itself, not connected, not dependent on the instance. And by doing that, if I restore it in any other server, logical, physical, whatever, if I restore it in any other server, as long as the server is in Azure and it can authenticate to the Azure, there will be no orphan database user. So this is a way more resilient and easier to restore in case I have to restore my database someplace else, and keep the permissions granted to users. So this is how it works. That's the preferred way, avoiding using the SQL Server logical instance, but granting permission always through the Azure SQL Database. So with that in mind, let me demonstrate to you how that works. And of course, I will go through the authentication, authorization, everything else on that topic. So let's go ahead and switch to the virtual machine. Here we are. My virtual machine is over here. So a quick flyby here on these virtual machines. I have a resource group here where actually, let me give you the whole scenario here. I'm running this virtual machine up in the cloud. I'm not running on my local computer, and this kind of mimics my headquarters, my central control, where I would manage anything in my cloud subscription. That's just the way I like to work. So everything is there in the cloud. My virtual machine, my central control place, and within this virtual machine, I do have a local SQL server. So if I go here and start my management studio, let's bring it up. You'll be here in a second. So I have a local SQL server on my computer. So that mimics an on-premise SQL Server deployment because it's running from a VM, right? It's running on my VM. It's usually what we see down there on regular enterprises. And I also have a server up in the cloud. So if I go here on the servers, and I look for the Wintellect server, I got this server created over here. Oh, nice, recover my files. So back to the cloud here. I have my Wintellect server here. And yeah, so this server here has one database already created over there. That's for a demo later down in this presentation on Always Encrypted. So there is one here, but there is just one, right? And if I want to create a new database must always be connected to the server. So, when you create the server, like I mentioned before, if I go here and go back to the servers and say, you know what, let's add a new SQL server in here. I have to select which subscription will be paying for that particular server. That deployment. Actually, the server is kind of free, right? The server itself doesn't have a price tag unless if we are doing Elastic pools. But in any case, I'm gonna select here a resource group where my database will be created. So don't create this one. It's just to show you some specifics in here. Always choose the region where you want your resource to be deployed. And here we go. See, SQL Server admin login. This guy here is this particular element in my slide deck. It's this guy here, right? The SQL Server login. So on the Azure SQL Server, you create one of these guys here for people to authenticate. But usually this is just the administrator. This is kind of the SA guy using username and password only for authentication, right? So yeah, so this is just the demo here to show you how to create. I have already created my SQL Server instance, and I think I closed my browser. That was not my intention. I just want to go back one level. So let me go back to the browser there, just quick here. And this Hotmail account, please do not email me anything in this account. Everything that lands there usually goes straight to trash. And just use it as my ID for some of my Microsoft benefits. Okay, so back to the server. Here's my server. Now I want to create a database on this server here, right? And so let's get this going and we can see how that works. So I'm gonna create here my Star Wars database. Kind of use the Star Wars theme for my presentations. And this will be on my Wintellect server. Perfect. What else? Elastic Pool, no, for this time. This is the price tier I'll be using for this one here. I'm gonna keep this the default. I'm not gonna change this one here, just letting go. So while it is creating that database, let's switch back to on-premise. Let's do here local Windows authentication, and we go back to that one over there later. Get this guy on, get this guy on. And I do have a couple queries here, but don't worry about these queries. We see these queries working on the other database later. So here we are. This virtual machine is also domain controller. Not a good setup, right? But you know, just for demos, that's okay. And in my domain here, I do have some users. So if I go on Windows Administrative Tools, and I get Active Directory using computers, you will see that I have here a user called Yoda. Yoda is the only one on my local on-premise Active Directory, right? My local network. So I get Yoda here, and I need to grant Yoda permission to connect to my SQL Server. Again, this is just a review, so we can make connect the dots, make the bridges in between on-premise and Azure SQL Server. So let's go ahead and give grant Yoda permissions into the database. So let's switch back to this Management Studio. Let's take a look on our instance. I do have a database here, a local database called Rebels. So that's my my database over there. I think I have a table in here. Yeah, fighters, got a little table in here. And like I said, I have to grant Yoda permissions to get in here. So to grant Yoda permissions on my database, I have to go here into the security folder of the local instance, right click on logins, go into the logins dialog box and search for Yoda in my directory service, in my local Active Directory, Windows Active Directory. There is it. And I got the account in there. And after coming up with the account, adding the account in here on the server level, on the instance level, I also have to go here into the user mappings and tell SQL Server that I want to grant Yoda permission on this particular database in here. And I'm gonna make Yoda DB owner in this one just to make it simpler. And just for fun, out of curiosity, we're gonna script this out so you can see how that's gonna work up in the cloud. So that is Yoda added to the database and to the instance. Again, important point, right? We are adding Yoda both to the instance and to the database. So Yoda can have access to the database because this database is not self-contained. So Yoda is there on the security level for the instance, down here, Yoda on the security level for the instance, as well as on the database level for my particular database right here. So Yoda shows up on 2 levels, right? And again, like I said, if you go here to properties and look into options, we can see that the database is not self-contained. It says none for containment type, which means is the traditional one, the way you are working with it right now. So that's how we would do it on premise. By now my database should be already created, so let me minimize my management studio, and I don't need the user and computers anymore from Active Directory. So if I go down here, now I see my database, Star Wars, and the other one that I already had over there before, right? So here on Star Wars, this is where I want to have Yoda in, which means that if I want to give permission to Yoda, I'm in the wrong, to connect to that database, I'm in the wrong place right now. I cannot give Yoda permission to get connected to that database from here, from the portal at the server level. Notice that I'm at the server level over here. On the server level, what I can do is I can give people permission to control the service, like I mentioned before. So if I look in here, I have a bunch of Star Wars people over here. Yoda is on my user list. I have already created Yoda on my tenant in this particular Azure subscription. So if I go here and look at Yoda, Yoda doesn't have any permission on the instance level, and Yoda is not an Azure person, right? It's not an Azure DBA guy, so it really doesn't need permission over here. Because if I really want to give Yoda permission at this level, I will see, sorry, I will see that when I type here Yoda, I can see Yoda over here. And when I look into the roles, if I look at all of these roles that are in here, like SQL contributor, it tells you right there, you see, lets you manage databases, but not access. It does not give you access to those databases. So you can handle the databases, you can handle the service, you can create new databases, you can drop databases, do backup on the databases, and I mean, you don't have to do backups on the databases, but you can restore the databases, but you cannot connect to the database. You cannot run queries against the database. So like I said before, there is no needs, there is, we don't grant permissions into the database in Azure SQL Database through the server level, right? The logical server level. The only exception for that, like I mentioned, is down here on Active Directory admin, the SQL Server admin. See, there is nobody here right now. So if I go in here and say, you know what, I want to give Yoda permission on this level here, like this, and select Yoda. At this point, this account is not a server admin yet, Active Directory admin for this server, because I have to hit save for that. But the point in here is, if I do hit save on this one here, Yoda will be able to connect to any database on this logical server. And usually that's not what you want to grant people. What you want to do for this particular setting here is either select one particular account that will be, the almighty guy, the SA guy on this particular server, or better yet, you can go again to the portal and go to Active Directory. It's coming. There we go. Go to Active Directory, go to groups, and you can add a new group, like it's a secured group from your Azure tenant, and you give it the group name like Rebel DBAs, and then you define description, whatever you want to do, assigned, and let's get the members in here. Keep in mind that Yoda is my user that I want to grant access to the database, not the almighty guy on my Azure platform, right? I don't want it to go and be able to manage the service. I just want it to work with the data in the service. So Yoda should not be my memory here. It should be someone that the company trusts on, that can be given that high level of permission. So in my particular case here, I'm gonna assign myself. I have this other account here that's also invited into the domain. I'm gonna add myself into the group, select, and create the group, and go back there to the management of the server, of the SQL server, and assign my my server. I'm gonna set my Active Directory admin to be the Rebel. Type it here first, clicking here first, and assign it to be the rebel group. This guy here, select, and off we go, right? Save it, and now I will be able, through my Windows account, my Azure Active Directory account, I will be able to manage the server and all the databases in this server because I am a Azure Active Directory admin. So now that that's done, let's go ahead and add Yoda and everybody else, anybody that wants to get in there, including groups, if I create other groups, into the database. So that cannot be done from here, from the portal. This is the server level. I don't want to give anybody permission from the server level. Let's go into the database level. So here's the database I just created. And if you go around here, you see that there are no options at this point to add users. There is no graphic user interface to add the users from here. The best thing that we have is kind of a miniature of the Azure Data Studio. In here is called the query editor. So I could come in here, click on the query editor, authenticate as myself, and add the scripts in there to create a user. But we have Management Studio, right? So let's go ahead into Management Studio and see what happens in here. So I'm going to go ahead and connect to my server, Intellect, but I'm not going to use my SQL authentication anymore. Now I got a Azure account that is able to manage this the server and all the databases in there. So I'm going to use that one, me@armandolasser.com, and my password. And keep it there, connect. So there we go. I have it connected over here. I see my database and I see my two databases out there. So if we go into Star Wars, which the one we are working with right now, and go into security, I see users over here. I can right click this guy, say I want to get a new user, and if it was on premise, we would get a graphic user interface to do that, right? But it's not on premise. When I click in here, what I get is command line. So in order to manage people who are able to log into the database and manage their permissions, as of today, we have to do this through command line, right? So that's how we do it. If this was a SQL Server authentication account, I would just go and create the user like it says over there. It's not associated to any login, and I would give the username in here, and I would assign the password right in here. And this is a hard-coded password, which is usually not a good idea. What we really want to do is to get users from our Active Directory, right? Granted in here. So what we do is I want to add, like, let's say Yoda at azuretraining.pro. There is no website with this domain name. It's just a tenant I created for my samples. And I would tell Azure SQL Database here that this thing comes from an external provider. Meaning, when I say this, it just means, look into Azure Active Directory if this account is there. And if it's in my tenant and I was authenticated in my tenant, go ahead and give that account permission to connect to my database. So let's check it out. There we go. We found Yoda. Yoda is available in, and it's available in AD, and it was just being granted permission into my Active Directory. If this is the traditional way in on-premise to add database roles, but there is a new T-SQL, right? A new command in T-SQL to add people, to grant people into roles. So we're gonna add Yoda as a database owner. So alter role database owner, yep. And let's add a new member. And the new member will be Yoda. Let's get this guy here. And execute. So now Yoda is DBO on the Star Wars database, right? Let's check it out. I'm gonna create a new query window here. I'm gonna change this guy here. It's not gonna be me anymore. It's gonna be Yoda at azuretraining.pro, and Yoda's password. And one thing that's very important here is usually we do just like this when we are on premise, because people get granted into the instance level, so they have read-only access to the master database. But when you do contained databases, they don't have access to the master database, so they cannot connect there. So what I gotta do is I must not forget to go here into the options and specify which database I want to connect to. And in this case, it will be Star Wars, right there on my object browser, Star Wars right there. So click connect, and there we go. Yoda, see down here, Yoda is connected, and Yoda can create a table. Create table Rebels members, and can get here a name, var char of 30, and we can have here the planet the guy is from, var char 30, and so on, right? Execute. Char, that doesn't exist. Char, come on, var char of 30. Oh, there we go, better. And if I go here, tables, I can see the newly created table over there. So I just granted Yoda the permission to work with Star Wars and Star Wars alone. Yoda cannot work with anybody else, any other database, I'd rather say. And of course, if I want to add a group, I can also do the same by coming back to my script. Where is the script? Here. I can come here to my script and have the group name over here instead of a username, and everybody in that group will be granted in the same way, right? So this is how it works. In summary, what we do is, if I go back here to my PowerPoint, in summary, what we do is we grant AD users permissions on the database, which is different from on-premise, that's granting people to the server first, the instance first, and then mapping to the database, right? That is the foundation for anything, any other feature and any other security elements you can have in there. Because some of the security elements, if you are a server admin, they're just bypassed, and you don't want them bypassed, right? So that's the way of doing it. Again, if you have any questions after this, after watching this video here, make sure you connect with me through one of the social medias or send me an email, and I will definitely go over your question. All right, so that's done. That's how we do authentication, authorization, all great. So the next two topics in there, it's managed identity and service principals. And the idea for managed identity is like if you create an application and users are coming to your application to see data from your database, what we want to do is you don't want to impersonate that user into the database. Because if you're going to do that, you're going to add a lot of users or a lot of groups where the users are from to be validated by the database. And that's usually a more cumbersome process because you have to go granular on all the groups as you have in AD and so on. A common project design actually gets an account for the application, and the DBAs, they will validate that account for the application, not the account for the entire collection of users you may have for your application. So the application validates who is connected to the application through authentication process there, and once the authentication is done, right, the user is validated, so then the application goes into the database as the application itself, not as the user. So how do I create, and that's important because if I create a user account, a regular user account, I have to do username and password, and then the password has to be hard-coded somewhere in some source code, and people will be able kind of seeing what the data, the password is, and maybe able to impersonate whoever the account represents or whatever application the account represents. That's bad for security, bad for auditing and paper trail. What we want to do here is creating an account that is passwordless. We don't want to have that account to have passwords, and we want to be able to grant applications the ability to use that particular account. So that's called service principals. So let's take a look here on how to create those service principals. Let's get back here to my virtual machine and back to the portal. And again, if I go back here to the Active Directory, let's take a look here at my directory over here. If I go down here into app registrations, this is what you want to do, right? I have one already there for one of my business partners, the Cloud Slice from Learn on Demand. So I'm gonna add here a new one, new registration. And here's a name like Rebel website user, I'm not user, right? So website maintenance, let's say. So that's the application I'm going for. I'm gonna use this particular ID on accounts. Then you choose where the account comes from, single tenant, multiple tenants, and so on. So that's gonna be a simple one, just simple. And here is the URI. It looks like a URL, but it's like a URI. It's actually a URI that the account must use to be able to request validation by this service. So in this case here, I'm gonna go http:// /Star Wars, and this is not a website like I said before. It is a URI, so it doesn't have to be a registered domain name. Star Wars dot Armando. And let's go ahead and register this guy here. So this is what developers would need, right? This is the application ID for app registration. And when developers need to authenticate their applications through this one here, they will need this application ID. They will need the name of the registered application, and also the URI. You can get source codes in here about how to do that. There are a couple of samples you can go in here, but we are not developers in here, right? We are actually DBA. So how do I do that? How do I assign permissions to this guy here once it is created? In the same way we added IOTA to the database, we go back there into the database and we say, you know what, I have another user to add in here. So create user, and the username is my application name, right? Rebel website maintenance. If I go back here to the Active Directory level, I see in the app registrations, this is the name, Rebel website maintenance. So I go back there and say, you know what, I have a new user, which is my application in this case. And like IOTA is from external provider. And because it exists in my AD tenant, when I run this statement here, is added. So Rebel applications authenticated using that application ID, they will be able to connect to my database right now. And if I want to give Rebel website maintenance, if I want to give that application the ability to write data to the database, I would have to add, add the account, the application account, to a role. And the roles are right here. If you can recall, if I go here into security and look at the roles, here are the roles, database roles, and the roles that I have in there are database reader and writer. So I'm gonna add these guys here, DB data reader, to my application account. And also a writer, database writer, to the same account. So if I execute these two statements in here, these two T-SQL, they go, and now applications that are authenticated by this application account will be able to both read and write, but not create new objects into my database. So that's how you do it. That's how you implement authorization and authentication through service principals. One of them, like we used here, the application registration, the application account, and that will avoid hard-coded passwords in anywhere, right? In source code or in configuration files or anything like that. And the other one that is also available, it works on the same principles and the same ideas, but it's actually for the VM. Instead of for being an application, it's actually for the VM. So if I want to create a VM where if I grant people access to that VM, they can run code into SQL Server without using their own account, but just because they're connected to SQL Server through my VM, I can do that by using managed identities, either system implemented or user defined. So to show you that, let's go back to the virtual machine here, and let's go back to the portal. It's the same principle, but it applies to the virtual machine. So if I go here into the virtual machine, I see I have another virtual machine here called Power BI, which is not running at this moment. And let's say, if people are connecting through this virtual machine and creating their dashboards and reports, I want them to be able to connect to my database regardless if they have permission to do that or not through their individual accounts. It's just because they're using this virtual machine. So if I go here into identities, I can switch it on, make it on and save it. So it's like, okay, we'll be creating one for this guy here. We'll be registering your domain. So it's doing the work. And like the other one before, right, I got my object ID here, my client ID. If I go back to Azure Active Directory, let's see here, Azure Active Directory, right here. So if I go back to Azure Active Directory and look into enterprise applications, and I'm gonna ask to see all the accounts that I have in here, all applications. If I search for Power BI, or Power BI altogether, there we go. I should be able to see the account that was created for me. And when I click on this guy here, I can see, the elements, how many times it has logged in, no time at all, not even once. But if I go in here, I can see the application ID, which would be required by the scripts, by the code running into the virtual machine to grab their token, the authentication token, use this application ID. But like the group we created before, and also like the application account we created before, the name of my account is Power BI. So in the same way, come on, help me out, there we go. So the same way I've done before, I can come in here and say, you know what, now I want to give permission to that virtual machine, the Power BI virtual machine, and authorize it inside my database. So with that, any application and any user connected through their virtual machine, once they recover an authentication token from the authentication service in Azure AD, they will be able to connect to my database, to this particular database, from any application they run inside that virtual machine. So we have these three ways, and we can use them interchangeably the way we want, by application, by user, by virtual machine, to implement whatever kind of access to our websites. To our databases. So that's how you make your database more secure in terms of authentication and authorization, by using self-contained databases and the traditional AD groups or managed identities for applications, or for virtual machines, and service principals for applications. With that in mind, let's move on here to the next topic. The next topic is dynamic data masking. So the idea of the dynamic data masking is not encrypt the data in the database. Encryption is not involved here whatsoever. So the database may be encrypted at rest, and if people restore your database, they need to have the encryption key, otherwise the database will not be accessible whatsoever. Encryption can be data in transit, and you can use TLS for that, right? To get the database, the traffic encrypted from client to service. So these are all, there are other options. We're gonna see that in the next topic. This particular one here is not about encryption. This particular one here is about when people select the data, don't actually show the data, show just partially some aspects of the data, like the 4 digits of a social, for instance, or in some other cases, like, just don't show the data at all, just put something else in place. So let's take a look on how that works. That's a pretty easy, pretty simple one. So back here into my management studio, I'm connected as me here at this point. You know what? For that, I will need a user that's not ADB owner. So I'm going to authorize another user in here. Control C, Control V, and that user, let's say I want to bring, who do I want to bring? I want to bring Han Solo. Whoops. So Ham Solo. I think that's the account name I created for Ham Solo. And this is going to be DB data reader and data writer for Han Solo. Let's get that going. And Ham Solo is not there. Add Ham Solo first, right? So let me create an account here for Ham Solo as well. Let's get this guy here and add Ham Solo. Come on, come into the database. Whoops, too many O's there. Come into the database. There we go. And now let's add you to these roles. So you're added, perfect. And now Solo can come in. Let me have a connection authenticated as Han Solo. So Yoda, Han Solo, and the password. Connect. So there we go. Han Solo is here waiting to collect data. This is me, this is not a want, but Yoda is here somewhere. Let's take a look at Yoda's connection. Let me browse in here. Here's Yoda's connection, and Yoda created a table in here with 2 columns. And let's add some data to this table, right? So insert into Rebels members, values. So for name, it would be something. And for planet, it would be like Jakku. It's one of the planets there, right? In the Star Wars universe. So let's get this guy in. We can have something else. Let's say something else, and this guy here is from Earth, so visitor from Earth. And execute this guy. So now I have 2 rows in there. Select star from Rebels, and Yoda can see the data. Everything looks fine, but like I said, I want to mask or not show the data from one of these columns. So what we do is I go back to the portal on the database. So I'm looking at the database right here, and what I do in the security settings, I have dynamic data masking. So I'm gonna click here on dynamic data masking, and I'm gonna add a new mask policy, a new mask rule actually is the name of the thing. And the Rebels database, so I have the name and I have the planet. So let's say I want to keep the planet masked out, right? I don't want to show the entire column. So I have some options in here about how to encrypt this thing, or I just, you can use a fixed one. So I'll go back in here, and what do I want to expose? I want the prefix and suffix, and say I don't want to expose anything. I'm going to be 0 and 0, so there will be no data on that particular column. I'm going to add this guy, and there will be no data coming out from queries, right? I'd rather say. And save this policy. Succeeded. It's there. If I go back to Management Studio, Yoda can still see the data. Data is right there. But if I connect as my friend Han Solo and do the same query, Han Solo cannot see the planet. The planet is masked out by that rule. And two things that are very important to understanding here is for administrators, whoever is the DB owner, the masks will never apply. They will always be able to see the data on a particular column. And the other thing is, again, this is not encrypted in the database. This table is not encrypted. The data is masked on the column in there. But if someone has access to Management Studio or they can run queries on their own, it's still possible to collect the data from that column. Like I'm gonna paste in here code that I have on my clipboard. And like you see, I'm creating a in-memory table here, right? Actually, a table variable, right? Let's say I'm creating a table variable here that keeps the data in memory, so I don't have to have permission to create a table in the database to do this. And I add a possible value that I think that it's there because Earth is a planet, and although I cannot see who is from planet Earth, I would like to join into using the column that I cannot see with the values I'm guessing. So when I run this particular script in here, I can see that the planet column is still masked out for me, but I can see the name. I can see that something else is actually from Earth because the join matched, right? I got the right join there. So keep in mind, this is one of the ways you can keep your database more secure in terms of when you collect data out, so developers would not show by mistake a value of a high sensitive column. But if people have access to tools like Management Studio or can do interactive queries, they can still try to guess data that is not showing from the regular table like this, right? So it's a nice feature, but not so secure. So that is data masking, right? Dynamic data masking. And the next security feature we're gonna see to wrap up this session is the always encrypted. And the main difference between this one and data mask, for instance, is the data is actually encrypted, and it is encrypted at the client side when the data departs the application. That's very different from, for instance, from transparent data encryption, TDE, which happens with data at rest when the data is at the database side, at the storage side. And it's also different from TLS when the data is encrypted while traveling from place to place. So always encrypted means the data is encrypted from the application all the way down to Azure SQL Database, and you cannot see the data unless if you have the security key, the hash key that was used to encrypt the data. It's the most secure option you have in Azure SQL Database to get your data private and or protected, right? And the idea here is we do that without disturbing the source code of the application, without adding any extra feature. The developer doesn't have to do any extra code to get the database encrypted. What we do is we set up the table and the columns in the table we want to get encrypted, as well as select the certificate we're going to use to encrypt that data. The certificate can come from multiple places, like it could come from Azure Key Vault, it could come from encryption key, your KPK. It could come from a certificate authority in your Active Directory. In this case here, we're going to use just the local machine, virtual machine, as the certificate repository to issue my certificate. But it can come from multiple places. So you apply that key, that's a particular certificate you got, to the encryption mechanism inside the database. So the client, when it sends the data to the database, it sends the data encrypted. And if you want to see that data, you must be connected with a client that would have permission to collect that same certificate in order to decrypt the data. So let me demonstrate that to you. In order to create the whole thing, it takes a little while, but I have a database already created, and I'm going to show you from there. So let me go back here to the virtual machine. So here's my Management Studio. I have already cleaned it up with the sessions in there. So here's my Star Wars encrypted database. I'm going to connect to Star Wars, new query, and I'm connecting as myself, me at armandolacerda.com. And I'm going to start adding permission to people so they can work with this database, right? We were demonstrating before on the Star Wars, so this is Star Wars encrypted. So let's create user hsolo at Azure training.pro from external provider. All right, Han Solo is in, and let's give Han Solo permissions on this database here. So alter role db data reader. Just want to select, right? So data reader should be okay. Add member, and the member is our Han Solo guy. So we got this guy there. Execute. Now Han Solo can read. So let's go ahead and add a new query with another authentication, another account. So change connections, and the connections here will be Han Solo. There we go. Connect. So now this session here is through Han Solo, and when Han Solo wants to do a select star from dbo.rebel members, my table that has encrypted columns. When I execute this guy here, oh, actually Han Solo got in the wrong database. So let's take the database from Star Wars to Star Wars encrypted. And the table naming here is different. So dbo.rebel, what's the table naming here? Table name is not showing. So let's get rebellion members. So let's get here rebellion members. And did I add Han Solo to the right database? This is Star Wars encrypted. Yeah, I did add Han Solo to the right database. So this should work. So there we go. The Azure SQL Database found the table. Han Solo was able to query from the table, but then Han Solo is lacking. I rather say Han Solo is lacking permissions, because when the table is encrypted, you cannot request columns. You don't have permission on this group, on this role in here. And to show that to you with more details, if I go back in here and look at the rebellion members table, you see that there is nothing in here that actually tells me that this column here is encrypted. There is no properties in here. If I want to encrypt, I can encrypt it right here, but this one is already encrypted. And if I go ahead and ask it to script this for me as a select to the clipboard, and I go column by column, like if I execute it, get the same error. But if I comment out rebellion and force string, encrypted these two guys in here, and run this, I can see the data. These are columns that really don't have any value in there, so I can see the data. But to see the actual encrypted values, I need to give permission to the user to be able to query columns that are encrypted. And we do that by doing this grant that was right there. So I execute this guy. This is the grant I'm supposed to give to Han Solo, the permission. So copy from here. Let's go back to my account, the me account, which has permissions to do these things. So grant this one to hsolo at Azure training.pro. And run this query. Now Han Solo has the grant that's needed. Let's execute this guy. And you see I have a similar permission, similar error, but actually this is a second grant that's also necessary. You have to be able to, the user trying to collect data from the column must be able to collect the metadata both from the master as well, the master definition, as well as the encryption key definition. So both of the user would need both permissions to do that. So let's get in here and add the second one in here, execute. And now once again, let's try the select. And now Han Solo can collect data from the table, but Han Solo cannot see the encrypted data. See, there is no data masking going on this one here. This is actually regular encrypted data. There's no way Han Solo can see this thing here, unless if it runs from the same user who encrypted this thing, and also has access to the encryption key. So if I am able to collect the encryption key for this one, what I can do is I can change my connection options. I must change my connection options in here to here on the additional connection properties. I go here and add this option here, column encryption settings enabled. So when we add this option to the connection string of the application and is able to connect, the application will try, in this case Management Studio, the data driver will try to collect the encryption key, and Han Solo now is able to see the galactic social security number for the records that are in there, and the force strength, because Han Solo is on the computer. The connection is actually asking for the decryption of the data and is running on the computer where the certificate has been issued from. To make sure you understand that, I have another instance of Management Studio going on here on my local computer. This is actually my local computer. So let me close this one here. We don't need to see this. Let me go ahead and connect to our Star Wars database. Query options. Actually, no query options here. I want to change my connection. Change connection. And I want to connect to that guy over there using AD. So hsolo at Azure training.pro, and the password for Han Solo. And let's make sure we are in the right database. Star Wars encrypted. Star Wars encrypted, and also my option to. So everything looks the same here. Same user, same database, same option for encryption algorithm for always encrypted. And I connect, and I'm there. hsolo Star Wars encrypted. Everything looks the same. And if I go in and ask to select this data from this table here, select to clipboard and paste and execute my query. You see my query fails like it failed before, but for a different reason. And the reason here is I don't have the certificate. You need to get my certificate, and the certificate's not here because I'm connecting from a different machine, right? I'm connecting right now from my laptop. So if I go ahead and try to collect columns that are not encrypted, I execute, and I can see my encryption, I see the query working because I'm not collecting data from encrypted columns. But if I try to collect data from encrypted columns from a non-authorized environment, in this case just by not having the certificate key, my query fails. So the data is really encrypted, including for myself, like me, the Azure Active Directory admin, the server admin, right, in Azure. If I go in here and if I connect, let me go back to the virtual machine to do that one. It's easier from there. So if I go here and connect to a new query, create a new query here, let's see, new query, and now I'm connected with me. And if I go in and select this table, script table, select to clipboard and paste the command here. If I select this thing, you see I cannot see the data, even as a system admin. Unlike the data masking that would show the data, I still can't see the data from here, unless if I go in there, query options, if I go in there on the connection, change connection options, actually, yeah, options in here, log in, and log in as me, mondolacerda.com, and my password. Make sure this the database is still the same, Star Wars encrypted, and the option for encryption is still there. So with the option in there, then I can see the data. But if I don't ask that one, or even if I ask that one from another computer where they don't have access to that certificate key, or the application doesn't request that certification key, then I will not be able to see the data, right? So that does it for this session. This is how Always Encrypted works. It uses encryption keys to store the data. The data leaves the client application already encrypted, unlike TDE, like I mentioned before, and requires specific settings on the client application, which is that encryption column option in the connection string I just showed you, right? And I didn't write it there, but the user must have permission also in the database to see the metadata on the master and on the column, so we can double check which certificate is supposed to be used in there, right? So yeah, incurring that additional overhead of granting the permission. So that's how it works. Demo done. If you have any questions, again, like I mentioned before, just connect with me on the social media, or send me an email, right? Social media is better, so I can answer to you and other people can benefit from that. In any case, I hope you have enjoyed this session, and I see you on August 22nd for another session through the WeIntellect webinars. All right,